Okay, how you doing, everybody? It's Jay from graytoqueops. So we just want to do a quick video on, as the title states, when to use and when to not use FDM printing for functional parts. So there's a misconception from a lot of people that think, when you say 3D printing, they kind of have an idea in their head that it's like a replicator from Star Trek, where you just press a button and then the piece comes out. Obviously, that's not the case. There are a number of different processes for 3D printing, and there are different materials. Plastics, metals, organics are now starting to come into play. Even electronics. There's filaments that are conductive, so you're starting to see printing of I forget the term, but the green board, the computer board, PCB, I think it is. Anyways. So the point is that there's different processes. So FDM, being fused deposition modeling, the way that it works is by layer, it's heating up the plastic and basically injecting the plastic, or extruding is the better term, extruding the plastic in a set pattern on the one layer, and then raising up or lowering down, and then doing the next layer. So layer by layer, and the layer heights are 100. Well, in this case, I'm running this machine at 100 microns, so that's 0.1 millimeter height. So that's 10 layers it takes to make 1 millimeter of height. So it's got to do that layer, raise, do that layer, do that 10 times to make 1 millimeter. This is a 4 millimeter high part, so you get the idea. So this particular part is this is for a friend of mine whose son is racing RC cars competitively, and the part is no longer available for the particular chassis. So he approached me and said, can you reverse engineer this and produce it? And right from the get-go, we discussed it, and I said, yeah, I can do it, but the problem is that for the application, it's not going to be a strong enough part on my printer. Even if I was to, up the game and do a carbon reinforced nylon, fiber reinforced nylon, you're going to make the part stronger. But the problem is that this part is under dynamic load, dynamic stress, which means that it's getting its stresses from all angles, not all the time, but it does take load at particular times from any different angle. And the problem is, as I'll show you, is that when you go through that process of producing something layer by layer, you're looking at a cross section of how it's been layered. So it's hard to see, but you can see here where this was a very crude print. I sped up the print time to get this out at a quicker rate, so it's a little bit rough. So it makes it easy to see the layers. So like I said, this is 4 millimeters at a 100 micron resolution. It might be a little bit more than 4 millimeters, but regardless, so you're looking at 40 layers are in there to produce that part. And where this piece failed originally was in this corner, right there, because that's where the suspension upright was being held in place. So you take a big jump, or you rear end somebody or something like that, and bang, it splits the part right there. Now the way that this is produced, it's going to be a lot stronger in that area. It probably won't fail there. But because of the layers, you can actually see it started to crack already just by me putting the bolts in. So this part is not going to last under those conditions. It's not. I mean, if you're just driving around a parking lot or something like that, yeah, that's gonna do it. It's gonna do the job, right? But he's racing this thing. He's going over jumps competitively, qualifying, racing, right? Like week after week, this thing is going. It's a part that's known to fail, so it's going to fail regardless, I think. But you're not going to want to buy something like this for a pair of them. Buy them for like $10 or something, and you're replacing them every race. That makes no sense. So in this case, for a functional part, FDM printing was originally designed for doing prototypes, rapid prototypes. That's exactly what this is. This is a prototype for dimensional verification so that we can proceed to the next step which is having them, it'll still be 3D printed, but it's going to be printed on a machine that's probably worth about $250,000 US. Either an HP Ink Fusion or Jet Fusion, sorry, or a Stratasys system that will be an SLS machine, but at a much higher resolution, and doesn't have the layering issues where this one would have. This has a FDM printing is going to have an issue where on two axes the strength of it is very strong, but on one axis is always going to be weak, right? Which is your layer height. So a perfect example is this this mount that I had that I was using, and I put a little bit of stress on an angle on this, and it snapped, right? So if you take a look here, I've actually got this in the slicer so you can see. This is how the printer does it. So we start off at the bottom where it's flat. It makes sense to start a print on a flat surface, so that's how we print it. As it goes layer by layer, it goes up all the way through to the top into a ball, and you can see it's not going to fail there. It's not going to fail down at the bottom. It's going to fail right at the neck at its weakest point. And because it's done it layer by layer, it knows it, it's going to snap right there if it's going to fail. So one way to strengthen this is why in this particular application what I've done is I've given a provision for a bolt to go through there, so you can put tensioning load onto the part to support where it's going to be weak on that layer, so I don't have that problem again. So anyways, that's just a quick example as to why would you use particular parts for an FDM off of an FDM printer for a functional part. Under certain circumstances, under most circumstances, yeah, you can use it depending on what you're trying to do. But under this circumstance, with this type of part, it's not going to cut it. You're going to use this for what it was designed: rapid prototyping. Get the part out quickly, get it dimensionally verified, make like I think this one is version 9, right? Like quickly print it out. I think it takes about 30 minutes or something to print this, right? So you print it out, make some measurements, try it on like do your dimensional verification. Does it work? Yes or no? Go back to the computer, make a couple adjustments, print the next one out, print the next one out, print the next one out until you've got what you want, and then you can send the file off and have it produced in a material and a method that's going to have it survive and be durable in the application that it was intended for. So anyways, that's my quick rant on when to use and when not to use an FDM process printer for functional parts. Signing off, it's Jay from Gray2Cops. Thanks for watching.